Question 8. The curve C has equation px cubed plus qxy plus 3y squared is equal to 26, where p and q are constants. Part A, show that dy by dx is apx squared plus bqy, all divided by qx plus cy, where a, b and c are integers to be found. So, part A then, we're starting with our equation of the curve px cubed plus qxy plus 3y squared is equal to 26. And we want to find the derivative of this. Now, because this is an equation in terms of x and y, we're going to be using implicit differentiation in order to differentiate this. Now, with implicit differentiation, we're differentiating with respect to x, so anything just in terms of x is going to differentiate normally. The middle term here is in terms of x and y, so we'll need to use the product rule to differentiate this. And then when you're differentiating y with respect to x, we're using the chain rule. So we differentiate with respect to y and then multiply by dy by dx. So let's just have a little look at this middle term here, which we're going to use the product rule for. If you are able to do this in your head, that's great, but just for those who want a little bit more of a pointer, if I'm differentiating qxy, the product rule is as follows. So if we're differentiating two functions u and v, it's equal to v times du by dx plus u times dv by dx, and these are interchangeable. So let's let u equal qx and v equal y. Again, you could let u equal x and v equal qy. It's up to you. If I differentiate u with respect to x, I get q, and then differentiating v with respect to x, I get dy by dx. And so when I do the product rule and I do v times du, I get qy plus qx dy by dx. So again, you do not need to write all of this, but those of you who wish to see where my step comes from, this is where I'm getting it. So coming back to this, let's differentiate. Differentiating this with respect to x is just multiply by the power, so 3p x reduce the power by 1, 3px squared. My qxy is my product rule, as stated, so I have qy plus qx dy by dx. And then my last one, differentiate with respect to y, so that's 6y, and then multiply by dy by dx. And that's equal to my constant differentiated, which becomes 0. Now I want to group my dy by dx's together, so I'm going to subtract this 3px squared plus qy, which is qx dy by dx plus 6y dy by dx is equal to negative 3px squared minus qy. I want to take out the factor of dy by dx, and so dy by dx multiplied by qx plus 6y is equal to negative 3px squared minus qy. And then dividing both sides by qx plus 6y, I've got my dy by dx is equal to minus 3px squared minus qy over qx plus 6y, which is in the form that I wanted. Part B. So we are given that the point P minus 1 minus 4 lies on our curve C. The normal to C at the point P has an equation of 19x plus 26y plus 123 is equal to 0. And I want to find the value of P and Q. So I want to use these new bits of information here with the equations I have. And because I'm trying to find two unknowns, it's likely I'm going to be looking for some simultaneous equations. So we've got our point P lying on the curve. So we're looking at our first bullet point. So let's take our equation of the curve, px cubed plus qxy plus 3y squared, and let's put in our x and y coordinates for P. So minus 1, minus 4. So that gives us P lots of minus 1 cubed plus q times minus 1 times minus 4 plus 3 lots of minus 4 all squared is equal to 26. This gives us minus p plus 4q plus 48 is equal to 26. And so if we subtract 48 from both sides, I've got 4q minus p is equal to minus 22. So it's given me one equation in terms of q and p. So let's look at our second point now, which is that the normal to C at P has an equation of 19x plus 26y plus 123 is equal to 0. And so the gradient of the normal at this point is the negative reciprocal of the gradient of the tangent at this point. So if we rearrange this to get it in terms of y equals mx plus c, subtracting 19x and 123 from both sides of the equation gives me 26y is equal to minus 19x minus 123. And then dividing it all through by 26 gives me y in the form mx plus c. And so the bit I'm interested in is the gradient. So the gradient of this normal is negative 19 over 26, which means the gradient of the tangent at P is the negative reciprocal of this. So at P, my gradient is 26 over 19. Now I know my gradient, I can put that into the equation I've previously found. So substituting my gradient of 26 over 19, that's equal to my equation that I found in part A. So that's negative 3p times x squared. Remember, the point that we are using is the point P. So x is equal to minus 1. Y is equal to minus 4. So as B was minus 1, this is equal to 4q minus q. And then my C was 6. So this is minus q minus 24. Simplifying this right-hand side, just squaring my negative 1. And then multiplying all through by 19 minus q minus 24. So that gives me minus 26q minus 624 is equal to, times in this by 19, minus 57p plus 76q. And then adding 57p and subtracting 76q and then adding the 624 leaves me with 57p minus 102q is equal to 624, which is my second simultaneous equation. So let's bring over our first. So my first, I'm going to write it as the p then the q, just so that these are in line here. And now if I were to multiply this by 57, I've got negative 57p plus 228q is equal to minus 1254. And the reason I've done that is so that I can then add these two equations together to cancel the p's. And so that gives me 126q, that's 228, take away 102, is equal to minus 1254 plus 624 minus 630. Divide both sides by 126, gives me a q value of negative 5. Substituting that into this equation here is probably the nicest, so negative 20, p must be equal to 2.